In this chapter, we're going to explore the trigonometric functions. In the first semester of this course, we restricted ourselves to looking at acute angles, so angles just in the first quadrant. In this semester, in this chapter, we're going to branch out and look at trig functions in any of the quadrants, so on the whole circle. You might recall that when we defined the trig functions in the first semester, one of the ways we could do it is by looking at the unit circle. So this is a circle of radius 1 centered at the origin. And if I form this standard position angle, so measured counterclockwise from the positive x-axis, and see where that angle, the terminal side, intersects the circle right here, the coordinates of that point, the x-coordinate is cosine theta, the y-coordinate is sine theta. And so just really quickly, we could sort of see exactly why sine of 90 degrees is 1 and cosine of 90 degrees is 0. Sine of 180 degrees is 0. Cosine of 180 degrees is negative 1. When we know the values of sine and cosine, we can define, the other trig functions, or we can evaluate the other trig functions. Secant is the reciprocal of cosine, and cosecant is the reciprocal of sine. Tangent is just the ratio, sine over cosine. And cotangent is cosine over sine, which is the reciprocal of tangent. So we're going to stick with measuring degrees in measuring angles in degrees for now, but we'll also run into radians and find those useful. And if we know, actually we could do a quick exercise right now. Suppose we know the value of sine and cosine of 30 degrees. So this here tells us that cosine of 30 degrees is root 3 over 2, and sine of 30 degrees is a half. Because of the symmetry of the circle, knowing the values in the first quadrant, which we spent a bit of time on in the last semester, we can actually use that to figure out the values in the other quadrants. So this first angle here, this 150 degree, or the second quadrant angle, 150 degrees, that 150 degrees is the same as measuring 30 degrees up from the negative x-axis. It's really what we get if we take this known point here and just reflect it across the y-axis. And that means that the y-coordinate is the same, and the x-coordinate is just going to be the negative, minus root 3 over 2, positive 1/2. In the third quadrant, at 210, that's 30 degrees beyond the 180. So that's like taking this point up here that we just found and reflecting it down across the x-axis. So it will have the same x-coordinate, minus root 3 over 2, and a negative y-coordinate, negative 1/2. Over here in the fourth quadrant, 330 degrees, well, that's the same as just going backwards 30 degrees from the 360, or the 0 degree mark, the positive x-axis. And that's what we'll get if we just reflect this point down across the x-axis. So it'll have the same x-coordinate as the 30 degree point, positive root 3 over 2, and the negative of the y-coordinate, minus 1/2. So we had to do no calculating there, right? We were able to just observe based on the known values of 30 degrees and use the symmetry of the circle to help us get those other values. We get some immediate insights into the values of the trig functions when we kind of view them as points on the unit circle. So this says, without using our calculator, what is the sign of, and this here they just mean, is it positive or negative, of sine of 320 degrees, cosine 320 degrees, tangent 320 degrees. Well, 320 degrees, that's in quadrant 4, right? That's somewhere like here. So the y-coordinate is negative. That means that sine of 320 degrees has to be negative. I don't know what it is, but I know it's got to be negative. Cosine has to be positive. The x-coordinates are positive in quadrant 4, so this has to be positive. Again, I don't know what it is, but it's got to be positive. Now tangent, that'll be a little bit tricky. We just have to remember here that tan theta is the same as sine over cosine, so this is sine 320 degrees over cosine 320 degrees. And sine we said was negative, cosine we said was positive, and so tangent of 320 degrees is negative. All right, let's find values of the trig functions. Now, they don't tell us what the angle is, but they do tell us that the terminal side passes through the point negative 4, 3. Now, that point, negative 4, 3, is not a point on the unit circle. But I think we're still going to be able to use this and this information to figure out what these trig functions are. So the first thing I'm going to do, the only information they gave us is the coordinates of some point. So I'm going to just plot it. So here's the angle theta that we're looking for. Now, what I'm going to do is sort of think of it in reference to this angle here. When we pick kind of a reference angle, we always want to measure it from the x-axis. So in this case, the negative x-axis. I'm just going to call that alpha. You can call it whatever you want, as long as it's not theta, because we were already using that for a different angle. And then I'm just dropping down a perpendicular. And when we do this, we make a little right triangle. So now we can use the other kind of interpretation, or the other way we think about these trig functions, as being ratios of sides of a right triangle. What I'm going to do when we do this, our SOHCAHTOA will still work, right? The right triangle trig facts that we have will still work. But I'm going to think of the legs of this triangle as signed legs. So this length isn't just, I'm not just going to think of this as having length 4. I'm going to adopt that sign and say, well, it's got the length of negative 4. And then this is a positive 3. And then we want to figure out what this is. We could do that with Pythagoras. Pythagoras tells us that 3 squared plus negative 4 squared is equal to r squared. The parentheses around the negative 4 here are absolutely crucial, otherwise we won't get the correct result when we put it in the calculator. So 3 squared is 9, plus 16, that's 25. And taking the square root, we get r is equal to 5. R, this distance, right, what's the hypotenuse, this is always positive. So it's only the legs, right, these other sides of the right triangle that could have a negative value. And then we have SOHCAHTOA. They said find the values of the trig functions. They mean all of them, all 6 of them. We're going to start with just the 3 that we get from SOHCAHTOA. So let's see, this tells us that sine theta opposite over hypotenuse is 3 over 5. Cosine theta adjacent over hypotenuse is negative 4 over 5. And tan theta opposite over adjacent is 3 over negative 4, or negative 3/4. From each of these now, we're just going to find their reciprocal functions. So the reciprocal of sine is cosecant. It means cosecant theta is 5/3. Secant theta, that's the reciprocal of cosine, is negative 5/4. And cotan, which is the reciprocal of tangent, is negative 4/3. So the same techniques that we used in the first semester work. If you look back through your notes in the first semester pre-calculus, we did problems just like this one. It was just that we had restricted ourselves to angles that existed in the first quadrant. But our same techniques work. The difference is we're just allowing ourselves to consider angles in other quadrants, which means that some of them are going to take on negative values here. And we just allow ourselves to have a signed length of one or both of the legs of the right triangle.